All right, so we're starting a new chapter today, which is all about quadratic functions. The first section is graphing quadratic functions. You know, it's all blurry over here, but you got your book so you can tell. Right, today is just graph quadratic functions. We'll do the average rate of change later. The vocab that we're going to go through is the quadratic function, axis of symmetry, vertex, maximum, minimum, and then we'll look at the rate of change stuff tomorrow. So a quadratic function, it's a pretty necessary, important function, and that's because anything that battles gravity can be modeled by a quadratic function. So notice that all quadratic functions here come in this form: ax squared plus bx plus c. The a, b, and c are just the coefficients. And they name those terms down here. So some things that are going to show up often and that you definitely need to know about are down here. Okay, and some of these terms should be, kind of familiar to you. The first one that we look at is the y-intercept, and they say it's always c. Okay, so whatever this value is, even if it's 0, is going to be where the, and this is a quadratic function. It's also called a parabola. So where the parabola crosses the y-axis is always going to be c. Now, the reason for that is if you plug in the x value here at the y-axis, which would be 0, into your function, these two terms would cancel, and you'd just be left with c. So always, you can always find the y-intercept by plugging in 0 for x, but it's always going to be c in this. And again, if you think about what I was saying a second ago, that these are all can be modeled of anything fighting gravity, then this is going to be a very, very important point, because this would be the start of the, like maybe the rocket would shoot up, or the ball leaves the ground and things like that. Okay, so that's always C, so you're going to want to know that. The axis of symmetry, you should recognize that term, right? The axis of symmetry right here is just like any other symmetry, is what the function reflects over. And so remember, that would mean if you folded it in half on this line, everything would match up on either side. Then you can see they even point out that the reflection of the y-intercept is over here. So if that's the y-intercept, here's the reflection of it. Now, the axis of symmetry, notice that it always comes out of the vertex. So sometimes you're going to have a graph, and then you're going to just look for the vertex. The axis of symmetry will be the line, the vertical line that comes out of that. So another thing that's going to show up often is that you can find, if you're given the equation or the function instead, you can always find the axis of symmetry by using negative b over 2a, and they're talking about b here and a here. The negative means just take the opposite sign of b. It's not always negative, but the opposite sign of b when you plug it in. And when you answer this, it is a line, so you do want to say x equals whatever value you get out of there, and that's also true on the IXL. Then the vertex can be found if you know the axis of symmetry. Then the vertex, again, the axis of symmetry goes right through the vertex, so they share x values. So once you locate, once you find the x value of the axis of symmetry, you can just plug that into the function, okay, for any x value, simplify that, and that will give you the y value. All right, the vertex, what they're going to say down here, the vertex, we can refer to them as either a minimum or a maximum, okay? So if the parabola opens up like this one, then the vertex would be a minimum, okay? And so then you're looking for the y values. And if you think of domain and range, the y value would be the lowest point. So for this one, the range would be y is greater than whatever that y value is, okay? if it opens upside down, and I'll talk about what they're saying here in a second. If it opens upside down, then the vertex could be referred to as a maximum. And again, we're talking about the y value there when we say a maximum. Now you should be able to figure out if the vertex is a minimum or a maximum by just looking at the equation or the function. When a is positive, it will open up. When a is negative, it'll open down. So when a is positive, you'll have a minimum, and when a is negative, you'll have a maximum. All right, so I'm just going to work through the examples here, kind of using that information. And so they give us this function. They're asking us to graph it, x squared plus 2x minus 3, and also state the domain and the range. Okay, so first let's make sure we know what a, b, and c are, because that's what we're going to use to manipulate. Even though a is not there, it still counts as a 1. If you didn't have a x squared term, you wouldn't have a parabola at all. And b is positive 2, and c is negative 3. So make sure you grab the signs when you do this. And then they're reminding you here, right, c is the y-intercept. So the y-intercept is negative 3, or better if you write it as a coordinate, like that. All right. Next step will be to find the axis of symmetry. There's the formula. You need to know that one. X is equal to negative b over 2a, right? So they're just pulling these values off of what we've said here. So b is 2. We're going to have the opposite sign, 2 times 2. That's part of this 2 is part of the formula, and a is 1. So then when we simplify that down, it would be negative 2 over 2. So then the axis of symmetry is x equals negative 1. Again, the axis of symmetry comes straight out of the vertex. So if we have the axis of symmetry is x equals negative 1, we know the x coordinate of the vertex is also negative 1. And because a is positive, the vertex is going to be a minimum. Okay, so now they want you to graph the function by using a function table. Now you can go into using the graphing calculator. If you put this into y equals, then you can just go to the table and pull off all these values. Okay, but they're gonna work them out for you by hand. But again, I would, especially if you're gonna have to do it this many times, I would just put this into the y equals, go to the table, pull off these integers, and then that's a pretty easy way to do it. Okay. Okay, so I've entered it into the graphing calculator, and I'm evaluating each of these. Right, so when I plug in negative 3, that's what they're doing here, plugging in negative 3 and 3, we get out 0. So then that's a coordinate, negative 3, 0. When you plug in negative 2 and evaluate it, you should get a negative 3. So negative 2, negative 3 is down here. When you plug in negative 1, you get out a negative 4. So negative 1, negative 4. And that's our vertex. Remember, we use negative 1 for our vertex, or as our x value of the vertex. When we plug in 0, we get out negative 3. And then they messed up this. I don't know what that's going on. So, but when you plug in 1, you get out a 0. And that's this one. And so then once you know where your vertex are, where your vertex is, and you get a couple other points, then you just make a curved line and graph it that way. Now they're talking about domain and range. Remember, domain is your x values, okay? And I assume they want you to write this in set notation, Okay, so the answer to the domain for all quadratic functions is going to be all real numbers. So x such that x is an element of the real numbers. Okay, and that's going to be true that because, right, if we keep going out to the right or if we keep going out to the left, every one of those x values will eventually be hit by this curve. Okay, now the range, again, is the y values. So then we're looking at, for the vertex, the y value here at the vertex is -4. So then the range is going to be any y value that is bigger than -4, bigger than and equal to. Okay, so for this second example, we're going to compare the graph of f, which is the graph that they've given us, okay, with the graph of g, which we need some information for. Okay, and so, right, they're telling us that g has a y-intercept of -1, so I'm going to put that on the graph right now, if I can get to it right. It's somewhere right there. And a vertex at 1, 2. So I already have that on there. Okay, but some of the stuff they say, from the graph, f of x appears to have a maximum of 5. Okay, so they're looking up here to get the 5. Graph g using the given information. Okay, well, the vertex is at 1, 2. So the axis of symmetry is, remember, that's just the x value of the vertex. Okay, and so then we would have a vertical line coming out of that vertex there. The y-intercept they gave us is -1, so that's 0, -1 on the graph, and I've already put that one on there. If we reflect 0, -1 over the axis of symmetry, so we're here, here's the axis of symmetry, so then we reflect it to this point. So then that would be 3, -1 is also on the graph. Okay, connect the points with a smooth curve. So then it looks something like that. Okay, so then so blank is the maximum, so we're still talking about g, so 2 is the maximum. So then the question was, which function has a greater maximum? Well, then that would be our f, because that was at 5, so f of x has the greater maximum. All right, so we're going to look at this example problem now. It says a ski resort has extended hours on one holiday weekend per year. Last year, the resort sold 680 ski passes at $120 per holiday weekend pass. This year, the resort is considering a price increase. They estimate that for each $5 increase, they will sell 20 fewer holiday weekend passes. And so then the first thing is how much should they charge in order to maximize their profit? Okay, so let X represent the number of $5 price increases. And let P of X, or your Y value, represent the total amount of money generated. P of X is equal to the price of each pass, 120, plus every $5 increase we want, times the total number of passes sold, which is 680 minus, right, the 20x, because they're saying that 20 fewer holiday passes would be sold compared to previous year. So, right, they kind of told us everything we need. So the price times the total, and so that's what this is representing. And now you have to FOIL, and if you don't remember foiling, right, you're going to take 120 times 680 and get 81,600. and then you're going to do 120 times the negative 20x, and that's where the negative 2400x is. Now we're moving to the next term, 5x times 680, so 3,400x, and then finally 5x times negative 20x for the negative 120x squared. We're going to combine like terms now, and so that's the negative 2400x plus 3400x for 1000x. And so that was the equation for part A. And again, you know, what they're asking for is to maximize, and so you should be thinking of a vertex right now. And so we're going to take our axis of symmetry formula right here, figure out what the x value is. So b is 1000, 2 times negative 100, and take the negative of that. And so we have 5. All right, so remember that right, and they're telling you here, because A is negative, the vertex is a maximum. And so we found the axis of symmetry. And so what does all that mean? The ski resort will make the most money with 5 price increases. Okay? And so this is what they should charge, 120 plus the 5 increases of $5. So 120 plus 25 is 145 for each holiday weekend pass. Find the domain and range in the context of the situation. Okay, so then, you know, let's make sure we know what we're talking about. X represents the number of $5 price increases. So you could have 0 price increases, you know, and on the previous slide I said that parabolas have a domain of all reals no matter what, but of course you have to be in the context of the problem. You're not going to, if you're wanting to increase the price, you're not going to go negatively. And then it goes all the way to 34. And now the reason it goes to 34 is that any price increase after the 34th will start yielding a negative, what did I say y is again? A negative amount of money, right? So they don't want to lose money. And so, you know, so if you graph this, you would have something like this. And remember, your y values are how much money you make. Right here, the x value over here would be 34. And so then you can see after 34, like this would keep going, and so then you'd end up having negatives there. Again, we're not going to go into the negative. So the range of this is going to be 0 and all the way up to our y value of the vertex, and they didn't show us where that was. But we're going to do it down here, okay? And so that value, when we work all of that out, will be 84,100. Okay, and that's what our range is going to end up being up to. All right, so you should be able to do 1 to 12 at this point. Give the word problem a try, and it shouldn't be too bad. You just got to know those definitions from before and memorize that negative b over 2a.